Hello, I'm here to discuss the problem that we weren't able to discuss due to technical difficulties. So, I'm sorry about that, but let's start. So, the problem asks that we make a function that does the power or exponentiation without using multiplication, division, or exponentiation. So, an example of that is, for example, 5 raised to 3. We should get the output of 125 without using multiplication, division, or exponentiation. Okay? So what's the solution to this? Well, before we know about that, we need to learn two main things. First is that multiplication is just repeated addition. An example of that is 3 times 3 is equal to 3 plus 3 plus 3. Another thing to note is if exponentiation is just repeated multiplication. Another example here is 3 raised to 3 is just 3 times 3 times 3. Okay? Now, given that, we can conclude that 3 raised to 3 is equal to 3 times 3 times 3 is equal to 3 plus itself 9 times. So that is just 3 plus 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 3. Okay? All of these are equal to 27. So maybe you're asking, Coach Rigo, why are you teaching this? Well, it's really important for the program that we're gonna do later, okay? So what does this mean? It says that for every number x raised to exponent y, we just need to add x raised to y minus 1 to itself x times. To make that clearer, this just means that, for example, 3 raised to 3 is just equal to 3 raised to, look at the exponent here, y minus 1, 3 raised to 2 plus itself 3 times. So 3 raised to 3 is just equal to 3 raised to 2 plus 3 raised to 2 plus 3 raised to 2. Again, that cycle repeats. So 3 raised to 2 is just equal to 3 raised to 1 plus itself x amount of times, which is 3. So 3 raised to 2 is just equal to 3 plus 3 plus 3. Okay? So with those things in mind, let's get to coding. Stop share. All right, so here's the code for that. So let me discuss what this code does. First and foremost, of course, we need to ask the user for a number and its exponent. So here, for example, we ask for the number, put it into a number variable, ask for the exponent, and put it into the exponent variable. Then we print the function using those variables. Okay? So this is the function right here. As you can see, we didn't use multiplication, we did not use exponentiation, and we did not use division. So how does that work? Well, let me show you how it works by running this program. Select Python file. Okay, let's wait for that to load. Boop, boop, boop. So select number 3. So pause that, and next number 3, just like the example. There. So now we go into this line of code, which basically calls the power function, inputting the number that we put in, which is 3, and then inputting the exponent, which is 3. So it goes into this power function and into this first if and else statement clause. So first, it checks if the exponent is equal to 0. Well, you may ask, why does it check that? Well, as we've learned in math, any number raised to 0, except for infinity or 0 itself, except for infinity, is equal to 1. Okay? So we check for that base case here. So since our exponent is not equal to 0, hindi tayo papasok dyan sa if statement na yan. So we go directly to the else statement. Okay, so let me discuss these two variables here. This is the current total. This is the sum of all the numbers currently. And this at the bottom is the accumulator, which accumulates the sum. Okay, so I'm going to show you how that works first. So since the exponent is not zero, it's safe to assume that the exponent is 1 or at least greater. So to take into account for that, we set the current total to the number, which is 3. So this is equivalent as setting the current total to 3 raised to 1. Okay? To go down, the accumulator is 0 since wala pang ina-add sa kanya. Then we go to this function to this for loop right here. Okay? So do you remember what I discussed earlier? That multiplication is just repeated addition and exponentiation is just repeated multiplication. Okay? So this inside loop here, as you can see, is just addition. However, it's repeated n number of times, which is equal to the number. Okay? So this just means that this repeated addition here is just multiplication. Okay? And this bigger for loop right here is just repeated multiplication. So therefore, it is just exponentiation. Okay? So let me show you what I mean by that. Before that, let's discuss what happens here. The current total is equated to the accumulator, which the accumulator is equal to the current total here, added n number of times, which in our case is equal to number. And every time the multiplication ends, the accumulator is set to 0. So let's see how that works. So since yung exponent natin kanina, we assume this is 3 raised to 1, we can safely subtract 1 to the exponent here. Okay, so down, it enters the multiplication. So watch here. Okay, so down here, accumulator is equal to 0. It becomes 3. It'll loop again. Plus 3, magiging 6 here. And then plus 3, it'll be 9 here. See what happened there? Okay. So since the multiplication is done, that is 3 raised to 2, right? It'll exit out of that loop, set the current total to 3 raised to 2 or 9, which you will see here. Bam, it's 9. And it will set the accumulator to 0. Okay. Then it enters the loop again. So it'll repeat the multiplication since it is exponentiation. So it'll enter the multiplication again. Accumulator is equal to 9 plus is equal to 0 plus the current total, which is 9. It'll loop a number of times, which is 3. So 9 plus 9, 18, plus 9 again. It'll become 27. Then it will exit. Current total will be equal to the accumulator, which is 27, or 3 raised to 3. Okay? Now, if our exponent is larger, for example, 4, it will loop again. Pero since it is only 3 and we've looped 2 times already, since exponent minus 1, it's going to exit the loop already. So see here, and it will return the current total here. It will return 27, which is 3 raised to 3. Okay? So it will print 27 here. Oop, printed 27. And just to check kung tama, let's just use the exponentiation here, just for an error checking. And when we run that, you'll see that it's 27 as well. See, 27, 27. Now we can run this for any number that we want to check if it is correct. So let's say, 2 raised to 5, which is 32. Let's check 2 raised to 5, 32. Same process as before. Okay? And kita natin dito, tama naman siya. So thank you for watching. I hope you learned something. If you have any questions, just comment it down below. Okay? Don't stop my share.